95% off the input side of your bill. 2 settings. They stack. They stack.
95% off the input side of your bill. Not a model downgrade, not a shorter prompt, not a cheaper vendor. 2 settings that stack, and neither costs you a point of capability. Cached reads price at roughly 10% of input across all 3 majors. Batch takes 50% off everything. Run a cached prompt inside a batch job, and both discounts hit the same tokens. This is the AI cost engineering class from the Academy, compressed. 8 modules, 5 levers, every major provider. Pricing pulled from the live provider docs on April 29th. You get the whole framework in the next few minutes, including the part most cost content leaves out, which is the lever that tells you to stop optimizing and go do something else. 5 levers, in the order you should reach for them: cache, batch, route, compress, sovereign. The first 2 are free money, and you should turn them on before you do anything else, because they take capability away from nobody. Routing is where the real engineering starts. Compression means semantic caching, which only pays when your traffic actually repeats. And sovereign means local weights, which is the only lever on this list that comes with a hardware bill attached. The full class is on the site right now. 8 modules, about 5 hours if you take it slowly, 50 paste-ready prompts, and a decision matrix for every technique that tells you when not to use it. It is free. There is no sign-up, no email, no paywall, and no certificate. Link is in the description and pinned in the comments. Almost everyone gets the payoff math wrong, and it is 2 numbers. On the 5-minute window, the write costs 1.25 times input, and every read costs 1/10, so it pays for itself after 1 read. On the 1-hour window, the write costs double, so you need 2. And you read this off the usage block on the response, not off your invoice, because cache creation and cache read tokens are reported separately. If you are not logging those 2 fields, you cannot tell whether your cache works at all. The class names the trap directly. 4 explicit breakpoints, maximum, and the failure is putting 1 on content that changes. The cache matches an exact prefix, so the moment something early in your prompt moves, everything after that breakpoint misses. People put a timestamp or a session identifier in a system prompt, and then cannot work out why their hit rate collapsed. Stable content first, volatile content last. Here is the trick the module is built around. The discount stack. Take a $3 per million token input rate. Cache it and the read price is at 30 cents. Send that same cached read through batch, and it lands at 15 cents. 95% below base input. Same model, same prompt, same quality. What did you give up? Synchronous delivery. The job returns within 24 hours instead of immediately. On a nightly classification run, you gave up nothing. Semantic caching is a 3-layer pattern. Layer 1 is an exact hash match, nearly free, catching identical repeats. Layer 2 is a vector lookup, so a question that means the same thing as one you already answered comes back from your own store. Layer 3 is the actual API call, which you only reach when the first 2 miss. The tuning that matters is the similarity threshold, because set it too loose, and you will confidently serve the wrong cached answer, which is worse than a large bill. Routing carries the largest number in the class. A case study where classifier-based routing across a cheap, mid, and frontier tier saved $30,000 a month, deployed in about a week. Classify with the cheapest model you have, answer at the cheapest tier that can handle it, escalate only on low confidence. What bites you is silent drift. Your rules are correct the day you ship them. Your traffic mix moves over 2 months and nothing errors. It just quietly gets more expensive. The sovereign lever is running the weights yourself, and the class is honest about where it stops making sense. On a card you already own, break even against a hosted model lands around 480 queries a day. If you are buying the card for this, closer to 1,056. Below that, you are not saving money, you are buying a hobby, and that is fine as long as you know which one you are doing. This is the module that made me want to make the video. The class devotes a whole section to when not to optimize. If a workload costs $8 a month, an afternoon spent tiering it has a negative return, and knowing that is the actual discipline. Same with chasing a cheaper headline rate on long context, because some providers double input past a threshold, and the cheap one ends up costing more. And do not optimize before you can measure, because without per route metrics you cannot tell a working cache from a lucky week. The framing to keep is the one from Module 1. Cost regression is a quality regression. You would not ship a deploy that made your output worse, so do not ship one that makes every request more expensive. That means per route cost metrics before you touch a prompt, and a gate that fails a build when cost per request climbs without anyone deciding it should. So that is the framework. Turn on caching, turn on batching, put measurement in front of everything else, and only then start routing. Leave the $8 workloads alone. The full class has all 8 modules, the pricing table, the 50 prompts, and the decision matrices. Free, no sign-up, no paywall. Take what is useful.